Okay, good evening, everyone. I will try to explain you about what is object-oriented programming. Can you hear my voice clearly?
Yes.
Yes,
Yes, sir.
sir.
Okay,
Uh,
thank you very much. Okay, I will start. First of all, uh, currently there are two kind of programming concept, popular of programming concept. The first one would be structural programming, and the second one is the object-oriented programming concept. So the structural concept is an old-fashioned concept that recently it's been abandoned, or recently people turning around into the object-oriented programming concept. Why? Because it's better than the structural programming concept, of course. Most of you, maybe the current situation, or the new programmers probably never experience never experience a structural programming concept. They will be directly uh, conducting a programming by using the object-oriented process. So, but in this session, I will introduce you several, or I will introduce you just a piece of what is structural programming. Okay, so basically, a structural programming, a program will be break into a groups of functions. Okay, so by doing this case, if there is something, uh, if there's some mistakes in an application and you need to modify the application, the probability of the failure of the application is high, very high, because the function usually will be connected into another function, and the function also will be connected into another function. Then usually if you have an experience in creating an application, then you will know that application is a very complex and complex things. And to create an application usually consists of thousand, or maybe 10,000 or 100,000 line of code. So you can imagine that if there's something miss, or if there's something wrong with the line of code, probably that line of code is not alone. Probably that line of code is connected into another line of code, and also connected into another line of code. So if you are building the application by using the structural approach, then it will be a nightmare for you, because of why? Because of it is really hard to find out, or to figure it out, the connection between one line into another. So there is why, if there is a modification of the application, so you will have a higher chance to get the failure of the application, to get a whole application failure. So there is why this approach, or the structural approach, is being abandoned. So they are turning around into the object oriented. Why? Because basically the application or the program will be break into objects, and each object will consist of attribute and method. And so if there is a modification of the application, the failure will be clusterized, will be grouped into object, and it will only affect the object itself, not the other objects. Because we can say that object-oriented approach is a group of object, not a group of function, where an object consists of attribute and function. So as you can see, as you can imagine, previously a function will be bound by an app itself. So the boundaries for the function is at the application itself. But right now, by using the object-oriented, the boundaries of the function is only based on the object itself. So, so it means that the application will be break down into several kind of object that will be affecting only the object itself. So we can say that the program will be consist of many objects. Okay, and for example, in the structural approach, let's say we want to create a bicycle game simulation where the bicycle game simulation have several activity such as speed, the speed of the bicycle, shifting gear, and the trademark itself. So the step will be like, firstly, you have to define the variables of the gear, speed, and the trademark. And secondly, you need to create the function to increase the speed or decreasing the speed. And after that, you will try to operate the bicycle game simulation, like how to shift in the gear, how to define the name of the trademark of the bicycle, and so on. And the sample of the programming code would be like this. Let's say, firstly, you will create an apps called Speda structure, and then you will define the variable like trademark and speed and the gear, and then you give the value, you give a value into the variable like this one. And then the speed value, you give the value into the speed value from a function like this one. This is the function. You have two functions. First is increasing speed, and the secondly is the decreasing speed. Okay, and after that you try to print out, or you try to print out the result into the screen. And this one is the structural approach programming language, and the other one, or this one, is the object-oriented programming language. In the object-oriented programming approach, firstly you need to create an object. In this case, we need to create a bicycle object. So almost the same or almost similar with the structural approach, where you define a variable. Yes, this is the, the trademark of the bicycle, and then this is the speed, and then this is the gear. This is the variable, but in object-oriented approach, we call this with the name of attribute. So this is an attribute. In the structural programming, we call it variable. This is also a variable, but the variable in the class or in an object, we name it with attribute. So we can say that the bicycle object have an attribute, and the attribute not have a not have an attribute, yes, have attributes. We have two attributes of a bicycle. Sorry, three attributes of bicycle. The attributes are trademark, speed, and gear. So this is the attribute of the class or the object's bicycle. And this is the function or the method or the of the object bicycle. Okay, firstly, you firstly I will explain this as a method, but basically between this method and these two methods are different. Okay, the method of the bicycle actually is only two, which is increasing speed and decreasing speed. And what about this one? Is this a method? Yes, but this is a special method, or in a in an object programming language, we name it with constructor. Okay? This is a method to construct an object itself. So that is why the name of the method is the same with the name of the object. You can see this is the object is bicycle, or in Indonesia is sepeda, and the name of the method is also sepeda. So if you find out a method that have the same name with the object, so you can call it as a method constructor, or you can call only constructor. On the other hand, this is the method from the class or the object itself. So we can say that this object have three attributes and have two methods, which is increasing speed and decreasing speed. And this one is the main application or the main method. So after you create this class, and then you create the object by using this line of code. Okay, don't think it too hard. Just try to follow what I said in a surface level. So don't think about what kind of programming language should I. What is the function of this one? What is the function of this one? Not don't think it too deep. Just think it in the surface level first. All you need to understand in this level is only we have an object. The object consists of attributes and method. This is the basic level of object-oriented programming. So as we can see, this is the structural approach code writing code, and this is the object-oriented writing code. So in the object-oriented, you always create or you always define the object first, and then after finish creating the object, and then you create the main application. Unlike the structural approach, the between the main application and the function usually stand or usually written in the same section. So it will be confusing for several programmers, especially if you work as a group when you need to create an application and then the application will be divided into several portions. Then you have to have like a similar thinking, how to create, how to name the application, how to write the code or something else. So this is the basic imagination or basic image about the structural and the object-oriented approach. So this is only one object or uh, one thing. But what about if you want to have two objects or two bicycles? In the structural approach, we need to add more variable. We create second trademark, we create second speed, and we create the second gear, and then manipulate the value and print out into the screen. The application would be like, this is the first object, or this is the first bicycle, and then in the structural approach, we will create another line similar with the first line, only we identify them as trademark second second speed, second trademark, and second gear. And then we add another comment. similar, only differentiated with the number of 2. And then we did the same. Okay, this is the structural approach. But, sorry, not that. So the line of this code would be, in total, we have 12 lines for the structural approach. Unlike in object-oriented programming, where we have already have the class, so we don't have to define another attribute to create another byte. So the differences will be only in the main application. Like previously, to create one byte, you only create one object from class, class bicycle. So this is the object, and then this is the class. So you create the object from the class sepeda, or the bicycle class, and then you create by calling the constructor, and then you call the function. This is for the first byte. And then for the second byte, you conduct, or you also create the new object by using the same class. So there is no differences between the first class and then the second class. And then you call the constructor, and then you call the function. So in this way, the total line of code will be shrinking. So this is only 2 objects. What about if we want to create 10 or more bicycles? In the structural approach, we need to define the third tread mark, the third gear, the third speed, and so on until the 10th tread mark and the 10th gear. So you can imagine the line of code will be huge. But unlike in the object-oriented approach, where you don't have to modify the class or the main class of the bicycle, all you have to do is only creating the object by using the class that already exists. Confused? Do you have any question?
Not yet.
Okay, not yet? Okay.
Not yet, sir.
Me, sir, I want to ask you.
Okay, please.
Maybe for general, I understand, but I have a little confused about
Yes, it's okay.
what different about function, method, and behavior.
Okay, the difference is only the name. But in programming, they will all be called function.
Oh, okay.
Okay, this is only a matter of a point of view. So if in a designer's point of view, the function will be called behavior or will be called method. But in a programming point of view, all the behavior, all the method will be named as a function.
Okay, thank you, sir.
Okay, do you understand?
Yes.
Okay, thank you very much. It is okay to interrupt my explanation if you have confusion. It is okay for you to raise your hand and ask me directly while I'm explaining the material. Because I'm worried if you hold it and then after I finish, you can easily forget it, what you're going to ask. Okay? Take an easy approach about this class. Okay? Now, in object-oriented programming concept, basically there are 5 aspects. Okay? The first aspect is the object, and the second aspect is the class, and the third aspect is the encapsulation, and the fourth aspect is the inheritance concept, and the fifth aspect is the polymorphism aspect. Basically, this is the main aspect of the object-oriented programming. Okay, first we will define what is object. Object you need to have a solid understanding about object. The solid understanding is an object must have a state and must have a behavior. If we talk about the real object, then the object have to have two two things. The first thing is the state, and the second thing is the behavior. Okay, what is state and what is behavior for an object, for a real life object? Okay, a real life object have a state. State is an attribute. Okay, state is something to describe an object. Okay, let's say I have a human object, and what is the state or what is the attribute of a human object? I give you an example. The attribute of human, firstly, is the color of the hair. Okay, the nationality of the human, and the name of the human, birthday, uh, and then address. It can be the state or it can be the attribute of the object. In this case, it's a human object. So we can say state or attribute is something to define the object itself. So to define a human object, the attribute would be like the name of the object. So the name will define the human. Also, the the address of the human object will define the human object itself. So something to explain about the object. Okay. So until now, do you understand how to describe a state in this case? So let's say I have this. This is a handphone or a mobile phone object. Do you know what is the state of this object or this handphone or the or mobile phone?
Uh, Color.
Okay, the color of the mobile phone can be a state. And then what? The size.
Size.
The size of the phone can be the attribute.
RAM.
Sorry?
RAM.
Okay, the memory of the phone or the RAM of the phone can be the attribute. That is correct. So the attribute is something to define of an object. So do you understand until now how to define a state?
Yes. Yes, sir.
Yes,
Okay.
sir.
Okay. Now we move into another. We move into behavior. What is a behavior? Behavior is something that able to do that an object are able to do. Okay. Or we, in this case, we said that the ability of the object. So a human, what is the behavior of a human? Firstly, eating or walking, talking, everything, and that usually is the behavior of an object. So in this case, we can say that the behavior is the ability of the object. So in this case, back again to the mobile phone object. What do you think the behavior of this mobile phone object? Do you know?
Photo.
Taking photo. Okay, correct. And then the most important part.
Communicating.
Yes. Make a phone call. Messaging. Sending email. And so on. So you can differentiate between the state and behavior now? Do you think?
Yes, sir.
Yes, sir.
Okay, easy, right? So that's the real object. We're not getting into the, not the real object. We're getting into the application object. So how to change this object into an application object, that's another thing. So, but in this case, I just want you to have a wide image of an object. So basically, if you want to create an application, you need to define the object. And then after identify the object, you need to define the state and the behavior of the object. That's the main important things. Failures to describe or to getting this information, that we can make sure that the application will also be failed. So next point, class. What is class? Class, as a definition, is a blueprint or a prototype of an object. So we can say that class is something to define an object. Or I give you a common example. We have a house as an object. And then what is the class? The class is the design of the class. Design of the house. Okay, so house as uh, a concrete object, we call this as an object. And then the design of the house, to create the house, we call this with class. So to be able to create a house, we need to build, or we need to create the class first, and then from the class we can create the house. So in this matter, object are, or object is the instance of the class. So we can create the object from the class. Do you understand?
Understand,
Yes, sir.
sir.
Understand, sir.
Still very easy, right? But please understand this easy part. So like the same as the object, the class also will be consist of uh, attribute and method, where attribute is inherit from the what's it, state, and the method is inherit from the behavior. So basically, this is something that you asked before. What is the difference between behavior, method, and function? They are the same. So in class, we name the state of an object as an attribute, and in class we name the behavior of an object as method. Okay, but basically they are the same. So from this class we can create a lot of objects. So what is inheritance? Inheritance is a new concept that being offered in an object-oriented approach, where in structural approach they cannot have this inheritance concept. Okay? Inheritance means legacy in direct language. So what is legacy? Let's say I have a human class. Okay, I have a human class. From a human class, I can break it into a student class and then a teacher's class. Okay, student, student, and teacher are all human. So let's say if human class have a name and human class have an address, so it means the student class and the teacher class also have the same attribute as the human class. So you don't have to define the name attribute and the address attribute in the student class and in the teacher's class because it's already defined in this main class. Or in this case, we name it human class. So if we already inherit a class into another class, so it means everything in this class have, the children will also have. Do you understand?
Yes, sir.
So if human have, like I said, have name and address, it means that the student and the teachers as an inheritance from the human class, they will also have the name and the address attribute. This is the concept of inheritance or legacy. So in this class, uh, for the clear explanation, the top of the class or human class in this case, we call it as a main class. And for the down part of the class or the student and the teacher class, we name it as a subclass, where the subclass is inherit from the main class. So everything in the main class will be given into the subclass. And also a subclass can have another subclass and so on. So you can imagine all the attribute and the, you don't have to write all the attribute and the method all over again for a similar class. Okay, and the fifth part would be polymorphism. What is polymorphism? This is also a new concept that being offered in object-oriented programming. So let's say you have a in this example you have an airplane. As a general airplane, an airplane can increase the speed, can fly, take off, and landing. But the reality is there are kinds of airplanes. Firstly, there are propeller airplanes, and then there are jet airplanes. Both of the plane, both of the planes have the ability to increase the speed, have the ability to fly, have the ability to take off, have the ability to land, right? But they are different. What's the difference? How to take off and how to land and how to increase the speed are different. Why? Because one using the jet engine and the other one are using the propeller engine. So how they increasing the speed or decreasing the speed and how do they fly are different. So by having this understanding, even though they are different, but the name of the function are not different. The fly function are still called fly, even though that how to fly is different, but they are still flying. So having this kind of situation, the concept of polymorphism accommodate this problem. Okay, so even though that you have the same action or the same function, but the, the, the content of the function can be different. Okay, or in easier way, let's say I have a remote. This one is a remote. This is a television remote, and this is the DVD remote. The TV remote cannot turn on the DVD. Also, the DVD cannot turn on the television. It only can turn on the object that belongs to them. Like I said, the remote, the television remote can only operate the television, and also the DVD remote can only operate the DVD. But both of them are still a remote. They have a power button, they have a volume button, they have a number button. Okay, the power button still have the same name between the television remote and the DVD remote, but the function is different. That's the kind of concept that being offered by the polymorphism concept. So in this case, in short, I can say that you can have the same name function with a different name, with a different content, or with a different line of codes. Unlike in a structural approach, you cannot have a same function name. You have to differentiate between one function into another function, even though that they have the same meaning. So you have to give another name. So in this, because of this, the function name will be like unclear. Let's say this one is shifting gear one, shifting gear object one, and then this one is shifting gear object two. They are the same, but in structural approach, they cannot have the same name. They have to different. They have to be different. That's the problem that we found in a structural approach. But by using the object-oriented, you can have the same increasing speed name function used by two different objects. Do you understand?
Yes.
Okay.
Yes, sir.
So this is the uh, basic concept of an object-oriented programming. So there are 5 aspects. Firstly, what? Objects. And the second one is what? Class. And the third one would be okay. And the fourth one would be inheritance.
Sorry, sir. Can you repeat?
So the aspect of the object-oriented programming would be 5 aspects, right?
Yes.
Yes.
The first aspect would be
Object.
Object.
The second aspect would be
Class.
Class.
the third aspect would be
Inheritance.
Inheritance.
Encapsulation.
sorry,
Encapsulation.
Encapsulation.
encapsulation. Okay. The fourth one would be
Inheritance.
and the fifth one would be polymorphism. Okay, what is encapsulation? I have not given the clear explanation or the clear slide in this one. Encapsulation I already mentioned before. Each class and encapsulate or consist or boundary. Each class bounding the attribute and the method. Okay. So encapsulation means a class we differentiate the attribute and the method with another object, with other object. It means that the object class will not interfere with the human class, or the the human class will not interfere the the student class also, they will not interfere with the teacher's class. So each object cannot interfere each other. Because of what? Because the the human object encapsulate itself. The teacher's object encapsulate itself, and the student object encapsulate itself. So in the theoretical side, they cannot know each other. They can only communicate. So the human object can only communicate to the student object, and also the student object can only communicate to the teacher's object without without interfering one another. So like I said before, if you modify the human object, then the teacher's object and the student object will not be disrupted, will not be involved in this modification. That's the encapsulation concept. Okay.
Okay, sir.
Okay, sir.
Any question? No? And
Not.
okay, the last part, alhamdulillah, the UML class diagram. UML class diagram atau Unified Modeling Language class diagram is a no, I cannot say it in a one sentence. So class diagram is part of the UML. So UML or Unified Modeling Language consists of 13 uh, 13 design approach. One of the approach is class diagram. So class diagram is part of the Unified Modeling Language design. So why do we need Unified Modeling Language? Unified Modeling Language is the design of the system or the design of the application. So if we want to create an application, then we need to create the design first. Okay, this is the normal application creation. So before you create an application, you need to create the design first. To design the object-oriented programming, you need a UML designer. Okay, so basically when you create an application, it's not necessary for you to okay, what do you want to create? I want to create a, let's say, store application. Okay, I will create it directly without thinking and so on. You can do that, but it's like let's say, it's like you're telling your employee, let's say you want to create a house. You just tell the employee, okay, I want a house. Try to build it. You need to create the wall, and then you place the doors, and then you place the windows, and then you move out to the roof without giving them any design or any architectural design. Do you think that can happen?
Oh,
Yes, that can happen, but the result will be disappointed, right?
yeah.
So that is why you need the UML designer, designer tools. So before, normally or ideally, you need to design the application first, and then you create the application. So unified modeling language is one of the tools to design the object-oriented programming. And one part of the UML called class diagram. So class diagram represent a class, and a class represent an object. So this is the connection between object, class, and class diagram. So firstly, you need to define the object, and then after the object already clear defined, you need to define the class, and then after you imagine the class, you write down this class into the diagram or class diagram. So like this one, you want to create a bicycle. You have a bicycle object, and then after that you define the attribute and the method of the object, and then after that you written down those attribute and those method into a class diagram like this one. So this is a bicycle class, consists of 3 attribute and consists of 3 method. So this is the class name, attribute, and this is the behavior. Okay, do you understand?
Yes.
Okay, and then after you create this one, and then you start to write your code uh, by writing down exactly the same order as this class diagram. Okay, to close this session, I will give you an exercise. In this exercise, it's very simple. You try to imagine that you are going to create an application. Okay, let's say a library application, mini market, rental, or everything. Then from that application, you try to define the object that will be used in the application. Okay, and after you already got the object, you try to define the attributes and the behavior for each object or each class. So let's say I want to create a mini market application. So the object that being involved in that application would be like the uh, cashiers, and would be like the 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 the, the, the object the the object itself, like uh, the goods that you want to sell. It will be the object. The goods can be anything like a pen, erasers, or a key, or anything else. It can be called as goods object. You don't have to create a pen object. You don't have to create a key object. You don't have to create another object. You have to be to widen up your point of view into what is this group of things will be called in a mini market site, in a mini market point of view. In my opinion, they will be called as goods. Okay? So pen, key, or matches will be called as a goods object, and the cashiers and the owner will become another object. And after you find out the object, the next process is you need to define the attribute and the method of the object. Let's say this pen or this matches. What what do we need? What kind of attribute that we need in the application? Do you have any imagination? the name of the goods, the price of the goods,
The amount.
the amount of the good. Yes. Okay, that's good. That is literally the name or the attribute that you can use, or you can use to define, or you can use to define the object for the mini market application point of view. After you create or after you define the attribute, and then you need to define the method. What do you think? The method of goods.
Sell.
Sell. Okay. And then
At the
Buy.
stock.
add stock. Okay. And then
Broken stock.
okay, that's good. Okay. So you already understand what I mean. So I believe this exercise is would be so easy, okay? But still, but still, I want you to get through this by doing it yourself. I want you to try to imagine. I want to create this application, and what do this application needs? What kind of object that that uh, that that will construct this application? Then define the attributes and the behavior for each object. Can you do that?
Yeah, yes, sir.
Okay. I think that's enough for the exercise for this today's meeting. So I still expected you to create a group room or group chat or something so we can communicate each other, and I will try to answer for every question that you ask, and I will try to explain it in a proper way. Okay, so
Okay.
please, for everyone, so for the head of the class, you can contact me after you create the group room or something. I